Afternoon. Thank you for introduction. My topic is related to cybersecurity indirectly because what we are doing is that we teach students in their cybersecurity skills. And the very popular way how to do that is through so-called capture the flag games. There are multi-level games where each level is focused for solving a specific cybersecurity task, and when the students are solve the task, they get a flag, which is a secret code that enables them to proceed to another level. To reach or to solve tasks, they can take help, hints, provide solution, and so on. And to be able to somehow assess students, they are gaining points for correct flags, and they are, on the other hand, penalized for taking hints, providing incorrect flags, and things like that. And through this hands-on training, the students, of course, learn from doing, but it's not enough. Trainees don't see various ways how to do things, multiple ways how to find a vulnerable server, for instance. If they are lucky, then they can get some feedback after the session from supervisors, but it's informal, and moreover, we want to support online playing without supervisors. So our goal was to improve impact of CTF games by providing valuable feedback right after the exercise so that the players can learn from their mistakes as soon as possible. And to reach this goal, it's necessary to somehow generate this feedback automatically from data. And moreover, the feedback has to be easy to decode because there is no space, or the students are just not willing to waste the time of learning some complex analytical tools. So we focused on visual feedback that will be easy to decode and provide valuable feedback to players. First, we defined with domain experts who was organizers of regular hands-on trainings or faculty. We defined three basic requirements that are put on this feedback. First requirement is to provide personalized feedback, which is person-centric view on the behavior of individual players, so that they can ask questions like, in which level did I lose my points and why, and so on. The second requirement is comparative feedback, so that the players can compare their behavior, their results with other players of the game. And the third requirement was to provide an overview of overall game results and features, which could be very important and useful, especially when one player plays multiple games, then he or she wants to compare their complicity and things like that. Having in mind these requirements, we designed two comparative visualizations. One is more simple, easy to decode, and provides an overview of score and time. And the second one is provides more details, more insight into score development. Here is the first one. As you can see, it combines simple solutions to visualizations. Results of individual players are represented by dots. Personal results of concrete particular player is represented by bigger dot. The upper part is decodes the final results of the game. The colored lines or bar charts below are results of individual levels. And every point represents the score, where the x-axis is time that was needed to reach this score, and the y-axis represents number of points. This view is interactive, so that the user can easily highlight the results of individual players, can look at details by hovering mouse on points, and so on. Whether this view is sufficiently easy to decode, we can check right now. Look at this picture and suppose that there are your results, and you have 5 seconds to answer the following question. Which level was your worst? Did you find it? I hope so. Is the 4th level, because this result means that the player get scored little points for a very long time, comparing with other players and comparing with other levels. The second view provides more insight into the score development in time. The score is encoded by polyline, and because there is quite a lot of data, then it's again interactive, where you can filter, zoom in, zoom out, filter information like which events are to be displayed, which results of which players are to be displayed. You can look at detailed information of individual events, and then you can compare behavior of individual players during the gameplay. To evaluate that these visualizations are useful, we defined 3 hypotheses. First was that the requirements that defined with domain experts are really reasonable and useful for players. Second hypothesis was that the visual feedback really helps players to get insight into the results. And the third hypothesis reflects the fact that there are usually multiple ways how to reach the goal, how to get some information. So we suppose that some visualizations or the reports are more useful for specific tasks. We conducted a field usability study with 60 attenders of summer school, and where they played a game, and then they solve 12 tasks that cover all 3 requirements. And here are the results. We proved that the requirements that we defined with domain experts are really meaningful. The players prefer exploration of personal results to over game results in comparison with others. What was surprising that they preferred more overall game results with the comparative feedback. Comparative feedback wasn't so important for them. That was a bit surprising to us. We also proved the second hypothesis, that the visualizations support trainees in their understanding of results. Players were able to complete given tasks correctly, and tasks were easy to solve with the visual feedback. The third hypothesis was verified only partially. We identified specific tasks across the requirements for which one of the visualization is more appropriate, but we didn't find any correlation between the 2 visualizations and the 3 types of requirements. To be honest, these results are a little bit uncertain due to some data limitations that are explained in the paper. So further inspection of these hypotheses is needed. We get evaluative feedback, especially one key observation we made, which is displayed in this slide. It's a drawback of the overview visualization, where in some cases this view can be confusing. Like here, if you have these results, this is again a result of particular player. And if you ask who reached the closest score to your score, then users tends to select these close points instead of these correct, which is far away. So to conclude, this preliminary story usability study proved that our visual feedback is meaningful and worth of further development. We already integrated this feedback to production gameplay environment, which is used regularly by students. And now we are working with extension because we have more detailed data about not only events, but commands that they use in the gameplay. So we extend these visualizations with this more detailed data to get better insight into the behavior of users. Okay, thank you.